This is a podcast on naming variable ionics. And the variable ions are the ones that are in general in the transition metal area. And you can recognize them because they are the ones in the right-hand corner that have more than one charge. Your other side of the periodic table does a better job of showing the multiple charges. I do have a couple on here for like example, zinc is a 2+, it'll never be anything else, but nickel, cobalt, and iron, even chromium and manganese, they have more than one charge, and again on the other side of the periodic table it is written. So if it has more than one charge, you have to denote that by using Roman numerals. For example, IV, etc. So let's start with FeI2. So if you were to name FeI2, you have to first of all come up with the name of Fe, and there is Fe. That is iron. And you have to recognize on there that it has more than one type of charge. And so you have to say which one it is. And you have to do a little guesswork. So you have two I's and you have one Fe. That one is just not written there. You can figure out the charge on I because it is over here. And it's a 1 minus. It's always a 1 minus. And therefore, the only variable you have is that one, which we'll just call x. And 2 times 1 is a 2 minus, and 1 times x must be the opposite of a 2 minus, so that x must be a 2 plus. I prefer my crisscross, that 2 most likely came from there, so that one's a 2 plus. You never write the charges down below, and that 1 most likely came from there, which is a 1 minus. That's my crisscross and drop method, or swap and drop method. So this iron is a Roman numeral 2, has to be in parentheses, and then you name I, which is iodide. Iodide, I spelled that right, good for me. So now we're going to name MnCl2, and that is manganese and chlorine. So we write out manganese. That is an element for men, maybe one man, manganese. And if you look at manganese, it's here, and it does have multiple charges. Look on the other side of your periodic table. So it's going to need a Roman numeral. Leave a space for a Roman numeral, and then I'll name Cl, which is chloride. Now I have to figure out what that Roman numeral is. I'm going to guess that that 2 came from there, which would make that a 2 plus, and there's an unwritten 1 there, and that must have come from there. And let's check, does that make sense? 1 times a 2 plus is a 2 plus, and a 2 times a 1 minus is a 2 minus, and those are equal and opposite, so it must be a 2 plus. So you have to put Roman numeral 2 in there. Now we're going to look at CuO. Cu is copper, so at least write out copper. And then O is oxide, so at least write that out. And then you go and look, find copper. There's copper. Copper has more than one charge. So I have to figure out which one we're using, and I have to use a Roman numeral to state that. So I'm going to need a Roman numeral in here. So I know I have one oxygen, and that's a 2 minus. It's a 2 minus because oxygen is in that group, and it's always a -2 or 2 minus. And I have one copper because nothing's written there. So if I have a 1 and a 1 and a 2 minus there, this number over here must be the same as the 2 minus but opposite in charge. It must be a 2 plus. Let's check. 1 times 2 is a 2 plus. 1 times 2 is a 2 minus. So they're equal and opposite and cancel each other out. So it's Roman numeral 2. My children are yelling at each other. Oh dear. Now let's try Cu2O. Again, Cu is copper. Hopefully you recognize that copper is one that has multiple charges. O is oxide. So at least get those two pieces down. You have to say which copper you're using. So we look at our Cu2O. We have one O, and it's a 2 minus charge, and we have 2 Cus. What must the charge be up here? So I go 1 times a 2 minus is a 2 minus. So 2 times what must equal a 2 plus, and it must be definitely not a 2, I'm going to say. It is, let's erase some of this. It is a 1 plus. So that 1 down there most likely did come from there, and that 2 there came from there. So it's a Roman numeral 1, so it's copper 1 oxide. Let's do one more of going from the formula to the name. So let's look at this one. It's PbO2. The name of Pb is lead, so we have lead. And lead is one that has a variable charge, so we're going to leave space for Roman numeral, and O is oxide. Now we have to figure out what the charges are. So we have 2 O's, and O is always a 2 minus. And we have 1 Pb. So we have an x up here, that's the one we're trying to find. So we really have 1 times x plus 2 times a 2 minus must equal 0. Well, that equals a minus 4. So 1x plus a minus 4 must equal 0. So that x must be plus 4. So 1 times a plus 4 plus a minus 4 adds up to 0. So that x must be a plus 4, which means our Roman numeral is an I and a V, which is 4. So it's lead Roman numeral 4 oxide. Now we'll go from the name to the formula. So here we have iron 3, and that tells you it's Fe, and that 3, Roman numeral 3, tells you it's a 3 plus, so it cut out a lot of work for you. Oxide is oxygen. I look it up, it's always a 2 minus, and now I have to figure out how many I need of each. I really prefer my crisscross method. A 3 is going to go there, and a 2 is going to go there, but with no charges. Those charges really occur in the fantasy world of charge land. So you have Fe2O3, and if you felt like you needed to check, you would have a little imaginary 2 minus there and a 3 plus there, and you'd go 3 times 2 minus is a 6 minus, and 2 times a 3 plus is a 6 plus, and so it all adds up to our magnificent neutral 0. Now let's try nickel 2 phosphide. Nickel is Ni. 2 means it's a 2 plus, that Roman numeral 2. Phosphide came from over here. It's a P with a 3 minus. Again, we're just going to switch the 3 there and the 2 there. That works most of the time. So Ni3, P2. The last one I'm going to do is chromium Roman numeral 3 nitride. Chromium, Cr. That 3, Roman numeral 3 means it's a 3 plus. Nitride is nitrogen. It's a 3 minus. If you just have one of those and one of those, your 3 plus and your 3 minus will cancel out. So you just really need 1 and 1, because one of each cancels them out. I wish you luck in doing your variable ionics.